All right, guys, so quadratic functions day 3. Today we're going to learn some new stuff about other forms of a quadratic function. So just to take a quick look back at what we've done so far, you can write a quadratic function in vertex form, and vertex form looks like this. And as you remember, the vertex of the parabola will be at hk, those coordinates, and a is sort of a scale factor that determines how tall or wide or up or down the parabola is. We also learned last time that you can write a quadratic function in factored form and what we call expanded form, which is also known as standard form. So it doesn't always look like vertex form, and these different forms also hold different clues to what the quadratic function does in different contexts. So factored form can be a monomial times a binomial. So a monomial is when you have a single term outside the parentheses and then a binomial, which is two terms added together inside the parentheses. And in this format, it's really easy to turn it to expanded form. You just take the term that's outside. Whoops, I'm moving the whole slide thing, didn't mean to. You take this term that's outside, and I'm going to grab an annotation tool to just quickly draw that. There we go. So you take this term, multiply it by that one, and then you multiply it by that one, and then that's what it expands to. 2x times x is 2x squared, and 2x times 4 is 8x. Today, we're going to do a quick lesson on how to go back from the expanded form to the factored form when there's a common factor, a single monomial that you can just factor out. So if you've already downloaded the Google Doc that goes with this video, we're going to start there. Okay, so here's the Google Doc. So we do a quick little review of how to go from factored form to expanded form. And I'm just going to type my answers in here. It's a little bit easier than drawing sometimes. So once again, you take the term that's outside the parentheses and you multiply it times both of the terms inside the parentheses. So x times 3x is 3x. I do control period to do the little superscript, squared. Control period again to go back down. Plus, and then x times 4 is 4x. Okay, this one has some positive and negative signs in it, so it may take a little bit of mental effort. But you start off with negative 2x times x, and that's negative 2x squared. And then you have negative 2x times negative 7, and negative 2x times negative 7, that's a negative times a negative, so it becomes a positive. So that's positive 14x, because negative 2 times negative 7 is positive 14, and then you have the x that comes along for the ride. The next one, see, I pulled a little curveball on you here. This one doesn't have an x in front of it, so it really is just the plain distributive property type of problems that you've known and loved all along. Negative 3 times x squared is negative 3x squared. And then negative 3 times minus 5, again, there's a negative times a negative, that becomes positive 15. So this is negative 3x squared plus 15. So then we come down to these in the table, and on these I didn't give you the factored form, I give you the expanded form, and we need to try to figure out how to work backwards. So the secret here is we look at both of these terms and we try to figure out what factors they have in common. So what are some things that we could divide out of both of these terms? So you might look at these and say definitely both of them have an x, and it looks like only one x is common because this term is x squared and this is a single x. So x can certainly be factored out. And then the negative 10 and 30 have a factor of 10. So we can also factor that one out. So the total of the common factors here is 10 and x. So we'll take 10x and we'll pull it outside the parentheses. And then you see what both of these have left once you've divided out 10x. So negative 10x squared divided by 10x. Negative 10 divided by 10 is negative 1. And then x squared divided by x is just x. And you know that if we have negative 1x, the 1 isn't needed, so it's just negative x. Then we have the term that says 30x. and we're going to divide out 10. 30 divided by 10 is positive 3, and x divided by x is just 1, and 3 times 1 is still just 3. So that's our factored form once we've factored out what's common. So 10x was common, we pulled it out, and 10x squared divided by 10x is negative x, and 30x divided by 10x is just 3. Kind of makes sense so far? This one might be a little more straightforward. So x squared plus 10x, look for what's common to both terms. They both have to have the same factor in common. And the only thing I see, yes, you see it too, is x. So we'll pull an x out of the parentheses. Oh goodness, that's a tiny x. Make it a big X. And then inside the parentheses, x squared divided by x is just x. And 10x divided by x is 10. So it's x times x plus 10. Again. So next problem down, 6x squared minus 12x. We're looking for factors that both of these terms have in common. 6x squared and negative 12x. Definitely there's an x again, because this one has an x squared and this one has a single x. And 6 and 12 also have a common factor. And you might be thinking 2, yes, 2. Might be thinking 3, yes, they have 3 in common, but the greatest common factor seems to be 6. 6 is divisible by 6, and 12 is also divisible by 6. So let's take 6 and x and pull them outside the parentheses. And then 6x squared divided by 6x is just x. And then negative 12x divided by 6x is just 2. Negative 12 divided by 6 is negative 2, and a negative divided by a positive is still a negative, remember? And then x divided by x is 1. We don't need to write 2 times 1, we'll just write 2. Okay, next one down. 14x squared minus 63. Ooh, this one is tricky because you want to take x out of both terms, but this one has an x squared, and this term has no x at all. So therefore, we can't say that x is a common factor to both of them. Is there anything else that's a common factor to both of them? Not 2, not 3. Wait, 14 and 63 are both divisible by 7, and that may be the greatest common factor. We'll pull 7 only outside the parentheses, and then inside the parentheses, 14x squared divided by 7 is 2x, control period to do that superscript, 2x squared, minus 63 divided by positive 7 is minus 9. And that is as factored as you can get that one without going into decimals and fractions. Okay, these down here are some extra problems if you want more practice, and the solutions are in a companion document that you'll see also listed with this video. So good luck doing factoring of binomial expressions, and in the next video we'll take expanding and factoring a little bit further and see what happens if you have a binomial times a binomial. See you then.